Hello, am I audible? Hello everyone, am I audible? Can you hear me?
Yes, sir, we can hear you.
Okay, everyone is here. You can switch on your videos now. Everyone, please switch on your videos. Please everyone switch on your videos. I'm asked to do that. Okay. All have not come. All of you are here. I guess Vanda was there in the last class. And one more. Nivedita, I guess. Two of them has not come by now. Any new faces that we see? Ritika is there. Okay. Hi Ritika. Rohit. Rohit, were you there in the last class? Rohit, am I audible? Rohit, are you there? You are not audible. Chitesh, hi Chitesh. Are you solving questions?
Hi, sir. Yes, sir.
Okay. Yeah, Ananya, are you new here?
Yes.
You joined just today, na?
I joined this year.
This class, we are doing physics here. So this is your first class now.
Yes, sir.
So have you taken the notes?
Yes, sir.
Okay. So you all, whoever has joined new to this session, new to this class, we have been doing the first chapter of physics and maths also, the sets, relation and function. You have to complete that. If you want me to repeat it, I'll be repeating you, but you have to wait after the class. Okay. As of now, what I'll try to do is I'll try to make you explain all of the new things that we are going to study. Okay. And then by that time you can go through the previous one. So I'll show you the screen. Okay, show you the notes so that you can take the screenshots and you study these notes. Okay, by the time if any doubt is there, then I'll be there. You can ask me. Right. So Ananya, did you try to read the first chapter of physics? Rohit, you also? I've not seen you.
Yes, sir. I read the first chapter.
You went through it?
Yes, sir.
Yes.
Okay. First chapter means not that physical world. I'm talking about this units and dimensions.
Yes, sir.
Thank you, sir. I got it. So in units and dimensions, we studied about the units, we studied about the dimensions. Okay, what are the uses of dimensions? What are the uses of dimensions? Ritika,
Sir,
what are the uses of dimensions?
uh,
Hmm? 3 uses. I made you write. You can see the notes. Three uses of dimensions. I made you write.
sir, sir, is it to check the correctness of the values
Yes.
and deriving the formulas
Yes.
and conversion of units from one system to another system?
Okay. That's correct. Rohit, did you join as Siddharth Malhotra in the last class? No. Then it
No,
was
sir,
someone
that was
else.
not me.
Okay. Okay. So see, Ananya and Rohit, I'll explain you dimensions because this is the topic that we have just started in the last class. Okay, and we are going through it. So if you understand this, you'll be able to solve the questions from it. And 3 basic topics that we can say that are present in this particular chapter are dimensions, errors, and one more thing is units. So units topic we already have done. We are doing dimensions, and errors we have to do in the coming session. Maybe we say that. Okay, so what you have to do, we have to understand the dimensions first. That I'll make you understand right now. I'll just give a brief revision kind of for you both so that you understand it, and that will be a kind of revision for Ratika and Chitesh also, right? So starting with dimensions, I'll give you time to take the screenshot of this note, so don't write anything because I think that won't be feasible now because I need to complete everything. Okay, so see here. This chapter starts with the units. Units, we have 2 types of units. I'll just give a brief revision. First type of unit is fundamental unit, and second one is derived unit. Fundamental unit and derived unit. What are the fundamental units? So fundamental quantities have got fundamental units. What are fundamental quantities? Like mass, time, length, temperature, quantity of matter, luminous intensity. These 7 quantities does not require any other quantity to get defined. For example, if I ask you to define velocity, how will you define velocity, Ananya?
It's the distance by time. I mean,
You can say that this displacement or distance by time. Okay.
displacement.
So what is displacement? Displacement is a kind of length, na? And time is already time. So you need length and time, the definition of length and time to define velocity, isn't it? Everyone? You require length and time to define velocity. So velocity is a derived quantity, and length and time, which do not require anything else to get defined. So those are fundamental quantities, right? So that is the difference between fundamental quantities and derived quantities. Okay. And their units are fundamental units and derived units. So in all, there are 7 fundamental quantities, so 7 fundamental units. Understood till here? Okay. Now I'm directly jumping to dimensions. What are dimensions? Order of magnitude and then dimensions. Okay. So what happened? We, in a situation, we tend to write the units of fundamental quantities as the dimensions. For example, there are 7 fundamental quantities. So 7 dimensional quantities are there. So mass is dimensionally written as m, length is dimensionally written as L, time is dimensionally written as time, Kelvin, ampere, candela, and mole. So these are dimensional units.
Sir, can you hear me?
Yeah, you are audible.
Sir, in the previous slide, there were only 6 fundamental quantities.
7. 6. 1, 2, 3,
Yes, sir,
4,
only
5.
time, length, mass, temperature, quantity in.
Oh yeah, current. It was left. Current is ampere. That was left. Total 7 fundamental quantities are there. Okay, nice observation. Good. I've written current here. I left it there. See here, current is there. 7 quantities are here, right? So what had happened? We tended to write the fundamental quantities in terms of dimensions. Why we are writing this? What is the requirement that I'll tell later? First, you understand is why, what we are doing actually. So mass we are writing m, length we are writing l, time we are writing t, Kelvin that is for temperature, that is k, and dimensions are always closed under square brackets. Okay, capital letter square brackets. Sometimes it is small only for candela and mole, right? So for example, if I want to represent density in terms of dimensions, so density is what? Mass upon volume. What is the unit of mass? Mass is kg and volume is meter cube. Agree everyone? So kg is what? Mass now. Kg is what? Mass. You have to represent this in fundamental quantities. The density is a derived quantity because it requires fundamental quantities to get defined. Okay, so kg is what? Mass, and that is raised to the power 1. So I'll write dimensionally m to the power 1. Then meter cube, that is length. So length is raised to the power -3. Are you getting my point? So this is how we have to write the dimensions. Similarly, area will have the dimension unit meter square. So dimension will be L square, mass 0 times 0. We can write the same thing as mass 0, L square times 0. Understood? Now, why we are doing this? So there are few uses of dimensions. First use is to derive the formula. I'll show you how. To check the consistency of the formula and to convert the unit. Okay. So first we learned about conversion of units. What was conversion of units? So for example, these are the various dimensions. For example, conversion of unit. See, any unit, any quantity, if I tell you, Rohit, if I tell you to measure this length, this is a wooden plank and you have to measure the length. And how will you, any measurement, how will you write the measurement? You'll say me, sir, it is 5 centimeter. You'll say me, sir, it is 10 centimeter. You'll say me, sir, it is 20 centimeter, something like that you'll say. So anything contains what? Any physical measurement contains what? Be it of any quantity, not only of length. So it contains a numerical value and a unit, isn't it? Every quantity, if I ask you to measure, you'll say me a numerical value on the unit, isn't it? You'll say like this now. So numerical value on the unit, this is a constant for a particular measurement. You can say me, sir, this is 0.05 meter, or you can say me, sir, this is 5 centimeter. But both are having the same quantities or not? Are they different? Are they different? Everyone? Chitesh?
Yes, sir.
Are they different? 0.05 meter and 5 centimeter. Are they different?
No, sir.
If I ask from Rohit to give me a length of 0.05 centimeter, 0.05 meter, and I ask from Chitesh to give me a length of 5 centimeter, won't you both be giving me the same value?
Yes, sir.
Okay, so that is there. So that's why N1 U1 should be equals to N2 U2. The first system of unit should be equals to second system of unit, whatever you go, whether it is SI or it is CGS system of unit. SI or CGS system of unit, right? So for example, if I had to convert 5 meter into how many centimeters, if I didn't know, okay, if I didn't know and I have the knowledge of units, conversion of units through dimensions. So what will I do? I'll write the unit of this quantity first. Okay, this unit U1 is written in dimensional quantities. So meter means length to the power 1. So that is M0, L1, T0. And in second hand side, we don't know the numerical value, but we know the unit. But again, this is only length of only. This is of length only. M0, L1, T0, right? But I'm writing L2 because it is in CGS unit, centigram second, and this is SI unit. SI unit of length is meter. This is CGS unit. Okay. So what will I do? I need to find this x. So I'll take this downwards. So M1 by M2, L1 by L2, T1 by T2 raised to their respective power. M1 is raised to the power 0, L1, T0. Okay. Now what is the M1 by M2 power 0? Whatever is there, if power is 0, what is the value? 1 only. Right? So what happens after it? L1 by L2 raised to the power 1. What is L1 and what is L2? L1 is the unit of length in meters. So L1 is what? 1 meter. L2 is the unit of length in centigram second unit. So it is 1 centimeter. How you divide 1 meter and 1 centimeter? You get 100. So it is 5 into 100. That is 500 centimeter. That's how we get it. Understood everyone or not? you may be partially understanding it, but did you understand it partially or not? At least partially?
No, sir, complete.
Completely. That good. I'm particularly asking for Ananya and Rohit, who have joined just today,
Yes, sir, I understand.
Understood, sir.
because I took nearly 1 hour session to explain this, and I'm just explaining in 5 to 10 minutes. So that's why I just try to give you an insight about it. Okay, just an insight. We'll move further. You'll understand everything. Understood? So let us move forward further today. Right. So today we'll be learning about conversion of system of units. We did checking the dimensional quantity. Checking the dimensional consistency of units. For example, if I say that V is equals to U plus AT, where V is final velocity, U is initial velocity, A is acceleration, and T is time. I'll try to explain all of the chapters which I've taught in these respects only. Okay, you'll understand everything. How to write dimensions, how to understand this, how to convert the units, and how to check the consistency. Okay, Ananya and Rohit, through this class, I'll try to explain you everything so that you can go and solve the previous questions also. So first you tell me, what is the dimension of velocity? This will be answered by Ananya and Rohit only, because both of you have done Chitesh and Ritika.
LT minus 1.
LT minus 1. Rohit, agree?
Yes, sir.
Okay, that's good.
Yes.
So it is LT minus 1, right? Now, LT minus 1, if the equation, the dimensional consistency says that if the equation is consistent, that means if both of them are equal, if this equation follows the order, so the left hand side dimension should be equal to the dimension of right hand side. Okay, the left hand side, because same unit you should get now. If you are getting some value meter per second on the left hand side, the calculation of the right hand side should also give you the meter per second only, isn't it? So this is what dimension says. So now tell me the dimension of initial velocity, same as final velocity, LT minus 1 only. Agree? Now what is the dimension of acceleration? Rohit will say
Sir, LT power minus 2.
LT power minus 2, very good. Plus LT minus 2, and that is to be multiplied by time into T. So I have to put them in square brackets. So LT minus 1 is equals to LT minus 1 plus, what will the calculation? Won't we get LT minus 1 here? Everyone?
Yes, sir.
Any doubts?
No, sir.
We calculate this, you'll get LT minus 1 only. And now tell me, if you add 2 LT minus 1, what will be the unit of that? If you add 2 units, 2 quantities of this unit, what will you get? If you add 2 pence with 2 pence, how many pence do you get?
4 pence, sir.
4 pence.
Is it 4 pence square?
No,
That
sir.
means adding of 2 quantities leaves the same unit, right or wrong? Right? So if you add 2 velocities, the resultant will only be a velocity, right? So instead of 2
Yes,
LT
sir.
minus 1, I can write 1 LT minus 1. So left hand side equates with right hand side. Hence, this equation is consistent. That means it is correct. Understood? This is how we check the consistency of an equation. Got it or not? Write it down, everyone. Everyone write it fast because we have to complete a lot today. But tell me, what is the dimension of a constant? Or you better tell me. You better tell me. Written, everyone? Shall we move on? Rohit, still writing?
No, sir. I finished.
Oh, we
No.
have two Rohits here, na? Okay, the Rohit with the guitar, I'll call you Rohit 1.
Sir, I finished.
Huh?
I finished it, sir.
Okay, good. Can't you not switch on your camera so that I can see you? If it is possible.
Yes, sir. I will try.
Now you check the consistency of this quantity. Kinetic energy is equals to half mv square. First, you find the dimensions of energy. What is energy? Any formula do you remember?
E equals mc square
E is equals to mc square.
or
Good.
mgh
Yeah, that's good. That's correct. That's correct. You can relate it from there.
and
Very
mgh.
good. MGH also, yeah, that is potential energy. Any form of energy has the same unit, whether be it potential energy or kinetic energy. So you find the dimensions of energy, put it on the left hand side, and then find the dimension of half mv square, put it on the right hand side, and check whether the left hand side and right hand side are equal or not. Check that.
Adarsh Vidisha this side. Good evening.
Good evening, ma'am.
Yes. Rohit, why your camera is not on?
No, I'm trying to on it. I will on it in a while. Just give me 5
Sorry?
minutes.
Okay. Switch on the camera, sir. Just
Yes, ma'am.
check for 5 to 10 minutes. If not, just remove him from the class. Yeah.
Okay, ma'am.
Okay. Thank you.
Thank you, ma'am. Did you get the unit of energy? Anybody?
Sir, I can't get your question.
Hmm?
Can you repeat the question?
Did you get the unit of energy?
Yes, sir.
How much?
ml square t minus 2.
ml square t minus 2. Anybody else got the same answer? Nobody? See, it's easy. If you can get the energy from any relation, you can relate it with anything. Any relation, you know, as he said that, sir, energy is equals to mgh. This is a kind of potential energy. You must have learned in class 9th. Isn't it? 8th or 9th, I think you must have learned this. So, and potential energy is mgh. Any form of energy, potential energy, magnetic energy, kinetic energy, electrical energy, whatever energy it is, energy has got the same unit, that is joules, isn't it? So energy, he said, sir, I am relating with mgh. So what is m? M corresponds to mass to the power 1. What is g? G corresponds to, sir, LT minus 2. G is a kind of acceleration due to gravity. So it is LT minus 2, and H is a kind of length into L. So it will be giving me ml square T minus 2. This is the dimensions of energy. Now check what is the dimension of this quantity. What is the dimension of this quantity? Put the values, it is easy. And be quick. Since you are targeting for competition, you have to be quick. Solving answer is not enough. You have to solve answer within time. Rohit, what is the dimension of this? Both the Rohit.
Sir, which one, sir?
Huh?
I asked which Rohit.
Both of you. Any of you can answer.
Yes, sir. M LT L square T power minus 2.
ML
Square T power minus 2.
minus 2. This is what you are getting.
Yes, sir.
And what dimension did you get for half?
Sir, half I didn't need a dimension because it's constant, sir.
Rohit 2.
Sir.
What answer did you get?
ml square.
Then?
Sir.
ML square, and after that?
That's
Okay. Everyone getting the same answer? Right, good. So half is a constant and that is not considered. Even if I write here, kinetic energy is 1/4 mv square. You know that this is wrong, but can you prove with dimensions that this is wrong? Can you prove with dimensions that this is wrong? No, you cannot prove. Why? Because we don't consider the constants. It will be removed. So dimension of this will be dimension of this. 1/4 has got no dimensions. So that's why we say that a dimensionally correct equation, need not be actual, need not actually be a correct equation. Okay, but if an equation is dimensionally incorrect, dimensionally inconsistent, then it must be wrong. So if this main equation is, if I write here mv cube, if I write kinetic energy as half mv cube, will you be equating these two equations? Will you get it consistent? No, you won't get it consistent because the dimensions of this will be different than the dimensions of this, because it should be mv square. But if I write 1/4 mv square, if I write 1/10 mv square, or if I write 9 mv square, whatever I may write, then you'll be getting it equal, because the main equation that is containing the variables are having the same dimensions. So if a quantity is dimensionally correct, that doesn't mean the quantity is correct. Okay, what is the factor? We don't know the constant, right? Understood, everyone? We don't know the constant value. That's why we cannot say that a particular quantity which is dimensionally consistent is always consistent. It may be wrong. That depends on the constant. Understood, everyone? But if it is wrong, that means there is some problem in a variable. Some variable is missing, or some variable is taken to incorrect powers. So that will be totally wrong. Understood this line, everyone? Say yes or no.
Yes, sir.
Everyone?
Yes, sir.
Okay. Chitesh, done?
Yes, sir.
Write it down. And check whether this equation is correct or not. Where S is displacement. U is initial velocity. T is time. A is acceleration. Do it fast. Done? What did he get? Consistent or inconsistent?
Inconsistent.
What is the problem then?
In,
Ananya?
in LHS, it's like L, but then in RHS, it's LP1 plus L.
LT1 plus L. Yeah, that's correct. Good. Good. Ritika? Did you get the same answer?
Yes, sir. I also got the same answer.
Good. Rohit, 1 and 2. Chitesh, same answer?
Sir, isn't it L?
Go on.
I mean, I got it as L equals L plus.
Any problem here? Shall I solve it? So if you write ut square, it is u, that is initial velocity at t minus 1, t square, that is time square. So if you multiply with it, you'll be getting L and t to the power minus 1 plus 2, that is plus 1. And half at t square, you'll get L. And on the left hand side, this is only L. So L, and this is a different unit and this is a different unit. How can you add two different units to get a different unit? This is not possible. So that's why this is inconsistent. Understood? Everyone?
Yes, sir.
Okay. So this was one of the way to you like one of the reasons to use the dimensions. Then the last one, that is to derive a physical quantity. Okay. Last topic on dimensions is to deduce a relation among the physical quantities. Okay, to deduce a relation among physical quantities. How we deduce that? For example, if I say you that in a certain condition, okay, in a certain condition, the force acting on a particle is directly proportional to the mass of that particular body. The force is directly proportional to velocity of the body, and the force is inversely proportional to the radius from which the force is being acted on the body. So you have to find the relationship, exact relationship between the force and m, v, and r. Okay, directly proportional may not be just directly proportional. It can be mv square, mv cube, mv to the power 4, like that it can go. So you have to find the exact relation. How we'll do that? So we'll write m on the left hand side and we'll combine all these things. So it can be written as m into v upon r. Agree, everyone? If it is directly proportional to mass, directly proportional to velocity, and inversely proportional to r, I can write it like this. Agree or not, everyone? Any doubt? Right? Now, to remove the proportionality sign, what we add a constant of proportionality, MVR. This constant of proportionality we cannot find. And that's why that is a lack, or that we can say that the disadvantage of dimensions, right? So we'll just write K in front of it and we won't work on it because this is a constant that we have added there. Okay, K is the constant of proportionality, different for different conditions. Now, m to the power a, it depends on m to the power a. I don't know the value of a, v to the power b, and c to the power r. Sorry, r to the power c. Okay. So this relationship is something like this, and we need to find a, b, and c values, right? Because we have already been told that it is directly proportional to m, v, and inversely proportional to r. Agree, everyone? Yes or no? Right? Okay. So what we have to do, we have to find the dimensions of F. Ananya will tell me the dimensions of force first. Ritika will check it.
NLT minus 2.
Is it correct?
Sir, what did she say? I wasn't able to hear it.
She said MLT minus 2.
Yes, sir, it is correct.
Very good. So shall we give some prize to Ananya? No, Ritika says no. I'll get the prize. Mass to the power A, velocity to the power B, and radius to the power. Or sometimes they won't be saying you that this is directly proportional to or inversely proportional to. So let us take that condition. We don't know this. We don't know this. We don't know anything. Let me use the adverse condition. in question, if you say that, if they say that, the question goes like this: F is somehow proportional to, somehow related to mass, velocity, and radius. Somehow, I don't know how. Okay, they may ask the question like this: F is somehow like related to, not even proportional to, related to mass, velocity, and radius. So I'll write it is directly proportional to mass to the power A, directly proportional to velocity to the power B, and directly proportional to radius to the power C. Okay, this is there. Now, this is a condition, like if we are swirling, let us say I've tied a knot to a stone. This is a stone, and I'm swirling it in a horizontal circle like this. So this is what force acting on it? Anyone? We have studied it. What force get acted on the body in this condition? Have you heard about centripetal force?
Yes, sir.
Right? It acts on you when you are taking a circle around like that, isn't it? So we are deriving the formula for centripetal force. Anybody know that formula? You know this. You're not applying your brain. mv square by r. Isn't it? You must have studied it earlier. So we are deriving it, but we don't know this. We don't know. We'll keep in mind that we don't know this. Okay. So F is somehow proportional to m to the power A, v to the power B, and r to the power C. Earlier I told you that it is inversely proportional to r. Okay. So r to the power C it is now. Now the second step, listen here carefully. If you understand this, you'll be able to solve all the questions of it. It is very easy. And such questions come in your JE also. Same questions, very easy there. So what you have to do, you have to write the dimensions of the left-hand side, that is the force that we know, and the dimensions of right-hand side. So mass, in the first bracket, we have mass. So m1 to the power A. Velocity is LT minus 1 to the power B. And radius is L only to the power C. Right, everyone? This is our second step. Now, I'm just telling you, if you have any doubt, just poke me out there. So it will be, if I can write it like, if I combine it, I'll get m to the power A if I multiply 1 with A. Then I'll get L to the power B and T to the power minus B. And I'll get L to the power C now. So now here it is m L T to the power minus 2. On the right hand side, it is m to the power A, L to the power, if I combine the length in all, it is B plus C and T to the power minus B. Agree or not, everyone? Everyone say yes or no?
Sir, how is it L to the power B plus C?
See here, we had one L here in the second term and one L here. Okay. We have one L here in the second term with the power B and one L here in the third term power C. What if you multiply any number with the same base and different powers? You add the powers now.
Yes, sir.
Right? So now what we have to do, we have to equate these two equations. Till here, everyone understood? You can nod your head. I can see you all. Everyone? Right? Good. So from here, what we see is that m should have the power of this m only. In order to get the same units of the left hand side and the right hand side, A should be equated with 1 because here power of mass is 1 only. B plus C should be equated with 1 because length has got power 1 here. And minus B from the time should be equated with minus 2. So from here we get B is equals to 2. Put B is equals to 2 in this equation. You'll get 2 plus C is equals to 1. You get C is equals to minus 1. Okay. So now I got the values of A, B, and C. A is 1, B is 2, C is minus 1. Put these values here in this equation. So from here we can get that, we can conclude that F is directly proportional to m to the power A is 1, B, V to the power B, B we get 2, and R to the power minus 1. So it is F is directly proportional to mv square upon R. And if you want to remove this proportionality sign, we can write it equal to and with a K because the constant we don't know. It may be half mv square upon R, it may be 4 mv square upon R. That constant we derive from physical experimentation. That we are not doing here. We are doing theory work here. And this is how we got the relation. But by physical experimentation, we know that this is equals to 1 because we know this formula mv square by R. Agree or not, everyone? Good. Good,
Sir.
good. Any doubt?
No, sir.
Very good. So write it down. This was the third point of dimensions. You have to solve as many questions as you can. Okay, there is no limit on questions. When I was at your age, I used to like dimensions a lot. It was something interesting to me. I don't know whether you are finding it interesting or not, but I'm trying to make it interesting. Do you like this? No? Written, shall we move on?
Yes, sir.
Okay, good. Next, we have to study about the dimensions part is over. Dimension has a huge aspect. This is over, but not over. Now, whenever you will be taught any new formula, the teacher, whoever you will be teaching, so they'll like ask you what is a dimension. So then and there you have to find that and then tell it to him. Whenever in this course of 11th and 12th, right? So try to focus on it. Try to solve as many questions as you can. Okay, then you'll be getting over it. This is really easy. Next topic is significant figures. Have you heard about it? Anyone? Significant figures.
So
Okay, I'll tell you. See, significant figures.
it's the number of reliable numbers in the scientific notation with one uncertain digit.
Pardon?
Significant figures is the number of certain digits in a scientific notation with one uncertain digit.
Exactly. There are certain digits that are scientifically noted, or like we have to count the number of digits in a particular answer, then we use the significant digit formula. Okay, that is not a particular formula. We have around 7 rules to write the significant figures. Okay, I'm just using those rules. Give me 1 minute. Okay, now see here, everybody, is it visible? Okay, now see, there are different rules to write the significant figures, right? You can take the screenshot and then you can write it at the end because it will take some time. That's why I just noted it. So what are significant figures? For example, if I say that I have a number 13.75 and somebody asks you what is the number of significant figures here? How many figures, how many like exact numbers, numerals are significant that can be counted here to write the physical notation? Yeah, correct, Ritika. That is 4. So there are 4 significant figures in the first figure. Rule number 1 says that all the non-zero numbers are significant. All the non-zero digits, if any number have 1.496, so there are 4 significant figures here. Okay, if it is 1497, 7342 like this, so it has got 6 significant figures, right? So it works like that. Second rule says that all the zeros between 2 non-zero digits are significant. So all the zeros between two non-zero digits are significant. It has given the example. If we are writing 100.05, 100.05 kilometer, so that has got how many significant figures? You have to add all of them because zeros in between numbers are significant. Understood? So basically, what was the use of it? So like somebody wrote the answer now, something like this, 0.0003. And somebody wrote the answer as 0.0003. But both of them got the same answer. So scientists were confused about a little like on this topic. How to calculate that what number you counted for and how much accurate you were. There are two terms basically, accuracy and precision. Will like see it later after this topic. So then you'll understand how much accurate it is, how much precise it is. So to gain that content, they used the significant figures and they said that both of them contains the same significant figures. So you both like use the same significant figures number you counted for. Okay, that was the use. Third thing, that third rule, it says that all zeros to the right of non-zero digit but the left of an understood decimal point are not significant figure. For example, if you're writing 86400, so decimal point has not been specified, right? But it is understood that decimal is somewhere here. It should be somewhere here. So to the left of an understood decimal point, the zeros are not significant figures. Only 3 significant figures are there in this particular term, right? Understood, everyone? Now,
Yes, sir.
such zeros are significant if they come from a measurement. Now, if I include seconds after it, 86400 seconds. So now you have to consider these two significant figures also. Okay, so total here it will be 5, but in just 86400 it is 3. So these type of question they may ask in JEE. There are questions. If you solve the previous year, you'll get these questions. The number of significant figures. So if you write anything, if you write even a dot, even if a decimal is present here, you have to count all the zeros. If decimal is not there, no ending is there, so you don't have to count the zeros after the non-digit number.
Sir, I have a doubt.
Go on.
Sir, 86400 is without seconds is significant or not?
Pardon?
86400 without this, I mean, without seconds is significant or not?
So if we are not considering the seconds, we are just writing 86400, no decimals. So only 3 significant figure will be there.
Sir, but the
We have to
fourth
leave-
rule says all zeros to the right of a non-zero digit, but to the left of a decimal point are significant. So if
Here
you
we did
consider
not
the-
specify the decimal. Here we did not specify the decimal. That is an understood decimal. Understood decimal. That means you understand that there is a decimal, but actually it is not there. You see here, they have not written the decimal here. No decimal is here. But here they describe the decimal 648,700 and the decimal is present. In that case, you have to count the zeros. Okay, this is quite confusing in the initial time, but when you solve questions, you'll get a habit of it. Okay, few of them you must have learned. These two are easy, first two are easy. Okay, so when you'll get a habit of it, it is easy, it becomes easy. So if unit is there, you have to count. If unit is not there, you don't have to count. If decimal is there, you have to count. Understood till point 4? Good. Now, next, all the zeros to the right of a decimal point are significant. So right of a decimal point, the zeros are significant. For example, if it is 161.0, 161.00. So here, 4 significant figures, here, 5 significant figures, right? This point is clear? All zeros to the right of decimal, but to the left of a non-zero number are not significant. For example, if we are something like this, 0.00161, so only 3 significant figures are there. Left of a non-zero number are not significant. Understood? And the last point, the number of significant figures does not depend on the system of unit. So whatever unit you have, you write it in kilometers, you write it in meters, you write it in centimeters, you write it decameter, whatever you write. The numbers, all these 6 rules we have to follow like that, and no change will be there in any system of units. So did you understand all these 7 points? Yes or no? You just read it once again, and any doubt you have, any example that you are framing and you have doubt over that, I can write it the significant figures. Get it? And read it once.
Sir,
Yeah,
sir, I just can't understand.
which one did you understand?
Not this, the one that comes after it.
Okay, 1 minute, 1 minute.
There'll be a part where it tells that anything with a countable object is infinity. Something like that.
I could not hear you. Please repeat that. Hmm?
Can you hear me, sir?
Yeah, you're audible.
Sir, the part where it, there's a rule that anything that has a count or it's like there'll be part where the significant figures will be infinity, right? So
Okay.
that part.
Oh, that one. See it. So basically, when we don't count anything, okay, we write something like this. I need to get that. If you write something like this here, 161, how many significant figures are there?
3.
3. But if I write it like this, then
4.
4 it is.
4. Yeah.
Now, can you, like, if I do
Sir, I
not
have it
specify it, just 1 minute, let me clear him first. If you do not specify the number of decimal points after which you are stopping it, so can't you write this as this, or this as this, or this as infinite number of zeros?
Yes, sir.
If you do not specify the end, then you can write it like this now. So how many significant
Yes.
figures are there here? Infinite significant figures.
Yes, sir.
Okay, so that's why you have to put a end sign, or you have to put the time, write the units. If you 161, after that you write seconds, you write kgs, you write anything. So it has to stop then and there itself. But if you don't write anything like this, or you don't show the end, so that will go till the infinity, and all of them will be counted.
Okay,
That
sir.
is an exception. We don't study that. We
Yes.
don't use that.
Okay,
Yeah,
sir.
Rohit.
Sir, what if it is 20.00? Is it 4 significant?
Yeah, that is 4 significant figures.
Sir, but the
20.00.
0 has no value.
See, we don't have to see the 0 has no value. Now I'll tell you how these significant figures are important. There are 2 terms: accuracy
Precision.
and precision. Okay, accuracy and precision. 1 minute. Yes. It refers to the closeness of any measurement, to the true value. Okay, and precision, it refers to the resolution or limit. It refers to the resolution or limit to which the quantity is measured. Quantity is measured. For example, if I have a length, okay, and that length exactly it is 161.23 meters. I'm saying that I gave this length to A and B, okay, and I asked them to measure. Both of them measured, and one said the answer 160.97684. Another one measured the same thing to be 161.220. So, you know, this is precise but not accurate, and this is accurate but not more precise than B,
Sir,
than A.
sir, but accurate must be 161.23, sir. Because
I'm saying that
accuracy is
near, not actually accurate, but I'm comparing it.
Approximate.
I should write more accurate, then it'll get more clear to you. More precise, more accurate. Now it's correct. Understanding that? Exactly accurate is 161.23. Now see what is accuracy and what is precise. So what A did, whatever mistake he did, that may be the mistake of the scale, that may be the mistake of its reading. Okay, but he went deep into the reading. He took as deep readings as possible. So he was more precise in the answer. Whatever method he took, he went deep into it. On the other hand, B, he took a small reading. Okay, he took the reading very small. He did not go deep inside it. Understood? If he would have got deep inside it, he must have got more near to the answer. So an answer should be accurate and precise. These two are different things. So now see 161.20 and 161.200 means what? The first one took the reading till the second decimal place and the third one took the reading to the third decimal place. That's why these are significant. Now did you understand? They have different meanings. Are you getting it or not? So second one is more precise than the first one.
But being more precise doesn't matter, because
we have different things. Sometimes we require precision. You may be asking that, sir, what is the work of precision if you're not getting the exact answer? So there are different things. We need to be precise also. We need to be accurate also in some cases. There are many scientific experimentations going on. So you need to be precise also. You need to be accurate also. Got it?
yes,
Everyone?
sir.
Any doubt?
Sir,
Now
I
understood.
have a doubt.
Yeah, go on.
Sir, in the previous slide.
Yeah.
In the third point, it says 86400 has 3 significant figures.
Right.
But with the second, it has 5 significant figures, you are saying.
Right.
But in the last point, it says the number of significant figure does not depend on system of units.
Right.
So, sir, so even without the second, it should have 5 decimal, right, sir?
Right. If it is 86400 meters, it will have 5 significant figures. Like putting a unit at the end means that I stopped then and there. Just writing 86400 doesn't mean that I stopped. I can put 0.00000 and I have to count all the zeros after that. So that's what Chitesh asked us. When it becomes infinity, it can become infinity. You can go till infinite zeros. So you have to state where did you stop. You have to either put a full stop there, or if you went beyond full stops, you have to write this much zero places, this much places I took. But if you're writing just the unit, that means you stopped there. Understood?
Sir, can you show this with an example?
Pardon?
Can you show this with an example?
Example, these are examples only. Now you measure anything, you get it like
No,
this.
sir, like I couldn't understand without an example.
Which one?
This comparison between the third and last.
Okay, see here. It says that, for example, if I have a number 164 centimeter, right? How many significant figures are there? Everyone.
5. 4.
Ritika?
Sir, 4, sir.
4. Now, if I write 1640 kilometer, how many it is?
4.
4.
That is what it's saying.
Sir, but
And if I write 1640, that's it. Then what is it showing?
still 4.
No, then 3.
3.
Because I did not specify the end. You have to specify the end, whatever the unit you may put. Doesn't matter. Now understood everyone? Rohit, Ananya, Ritika, Rohit, Tu and Chitesh. I want yes sir or no sir from all of you.
Yes.
Yes, sir.
Yes, sir.
Good. So this was accuracy and precision. You can write it down, the definition you can write, and then we'll move on to the last part of this chapter, that is errors. You all must be going to school.
Yes,
Have they started this chapter? I mean, ended this chapter?
yes, sir. Completed. So,
Okay, and then they must have gone to motion in one dimension, right?
not yet, sir.
Sir, they just started for me.
Okay, they just started. And Raghav sir, like, is he teaching you something right now?
Yes, yes, sir.
Okay. Right. What is he teaching? Motion in 1D? Okay, that's good. Try to focus on each and every concept, complete it now. If you do not get anything, so you have to complete those concepts by asking it repetitively. Keeping it for future will make you in trouble. Shall we move on? Good. So next we are starting with errors. Errors.
Sir, isn't errors deleted this time?
Pardon?
Sir, isn't errors deleted this time because of my school? I don't just ignore errors.
I could not hear you. Errors?
Errors, isn't errors deleted this time, sir?
Yeah.
Because my school just told ignore errors. They're not going to come.
Okay. They asked you to ignore errors. They have
Yes.
removed it or what?
Yes, sir. Deleted. Yes.
Okay. So we don't have to do that. Okay. I'll have to ask it then from my center if they'll be taking. Is this something that will they be asking this in JEE or advanced, mains or advanced?
I
Have they
think
removed?
they might.
They removed it from there.
No, sir, no. It's just the serious stuff.
So then we have to study this now,
Oh, yeah.
isn't it?
Yes, sir.
It's a very easy topic. Like you all are targeting for JEE, yes or no? So then you have to study this. Board syllabus is very easy. You'll get 90% like this. Doesn't matter. For boards, if you're preparing for nothing. You don't have to prepare for boards. By studying 4 hours in the last month of exam, you can score 90%. But if you want to get into good NITs, IITs, then you have to study 6 hours daily consistently. Not 10, not 12. I'm not asking for 24 hours study. 6 hours daily consistent. Every chapter to be covered, to be revised, and to be done, to be solved questions. The day you have studied it. If you have studied it right now, you have to solve it after going to the class. Okay. So errors. What is error? Error is change in any quantity from the true value. Deviation of the measurement from the true value is error, right? So there are few terms before we study the error. So first one, let us say that one is absolute error. What is absolute error? Absolute error. See here, what we did, we measured a quantity and we took different ratings, A1, A2, A3, A4. Okay, these were basic A and N readings we took for a particular measuring a particular quantity. And measurement doesn't mean just length only. Okay, I hope you're understanding that. I'm just taking an example. Measurement doesn't mean the length only. It means the weight, it means the anything, it might be. Doesn't matter. So there are N measurements. What will be the mean? How we calculated the mean? Mean is A1 plus A2 plus A3 dash 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 AN divided by N, sum of observation by number of observation. This is the mean value, right? And generally now, when we don't know the exact value of any quantity, what we do, we take N number of observation, we find the mean, and we assume that the mean is correct. Got it? Yes or no? We do that or not? We do that or not? Yes or no? We assume it to be correct, the mean value to be correct. So this is my mean value, and that I'm assuming it to be correct. So what is the error in the first measurement, delta A1? This is error in first measurement. Delta means small. Do you know this term delta? This small triangle, I'm using this. Are you familiar with this? That means
Yes, sir.
small change, small change. Okay. So error in first measurement. What is error in first measurement? So first measurement value minus the mean value, because I'm assuming the mean to be correct. This goes like this, right? Okay. Now, this is delta A2 error in second measurement, that is A2 minus A bar, or I shall write it like, I should assume the minimum mean should be more than that. I may assume anything. A mean minus A1, A mean minus A2. This is the error in the second quantity, right? So these are absolute error. Okay. So delta A is absolute error. What is absolute error? Magnitude of difference between true value and individually measured value. That's what we are doing. True value we are assumed to be mean one, and the individual measure value we are subtracting. We are getting these are absolute errors. Delta A1, delta A2 are absolute errors, and so on. We can get the delta AN, that is A bar minus AN value. Agree? Yes or no? Shall we move on to the next page? Written, everyone?
One
Yes, sir.
Okay. Shall we move on? Right. Now we have a term called mean error. So if we take the mean of all absolute errors, that is called the mean errors. That is the mean error. You can write it like delta A bar. A bar means mean. Then we have a term called relative error. Relative error. So that is denoted by delta A. That is the mean error divided by the mean value. Mean error by the mean value. For example, if we get in reading also one more thing, we representation of any quantity. Final result is expressed as A plus minus delta A bar. A mean plus minus delta A bar. For example, if I measured a quantity 2, 4, 5, 6, I'm taking the example, and the exact measurement was, let us say that it is 4.5. Okay, I'm giving an example. So exact measurement was 4.5, and my let us say that 4 of students measured the same quantity as 2, 4, 5, and 6. So what will we do? First, we'll calculate the absolute error. So for calculating the absolute error, what we do? We calculate the mean of it. A mean is what? 2 plus 4 plus 5 plus 6. You see your notes, the definitions which we have written in the order. First, we have to calculate the mean. So what is the mean of it? 10 plus 17 upon 2, that is 8.5. Right? 8.5. Am I correct? 17 upon 2 is 8.5, right? It is 8.5. Okay. So what we'll do? or we don't know the first. Let me tell you that we don't know this value. Oh, I'm sorry. Why I'm dividing it by 2? It should be divided by 4 now. You're not telling anything. 4 should be divided by 4 because number of observations divided by, sorry, total observation by divided number of observations. That's what we do. So now you're getting something like 4.25. Okay. And let us say that exact is 4.25 only. We are assuming it to be. Now what you have to do, you have to find the absolute error, delta A1 in the first measurement, that is 4.25 minus 2. Delta A2 is how much? 4.25 minus 4. Delta A3 is how much? 4.25 minus 5. And delta A4 is how much? 4.25 minus of 6. First value is 2.25, second value is 0.25, third value is 1.25 minus 1.25, and fourth value is minus 2.25, right? Everyone? Okay. Now what you have to find? You have to find the mean error. Okay, one more thing. In mean error, we don't take the negative values. Put the mod sign there. We take the mod, we take the positive values only. Okay, so we'll find the mean error, delta A bar. What is it? So 2.25 plus 0.25 plus, instead of minus 1.25, I'll be writing 1.25 because I have to take the mod, right? And, or I'll be writing, I shall write it, then you'll say that someone did not tell me. Plus minus 1.25 plus minus 2.25 and divided by the total number of observations, that is 4. Anyone tell me this value? Calculate and tell me this value.
Sir, I'm not sure, but is it -1?
I don't know. I'm just taking random values. You all match among yourself. Solve everyone.
9, sir.
How much did you say, Rohit?
-1.
-1. Ritika?
Sir, I'm doing it, sir.
Okay, do it. Chitesh?
So doing it, sir.
Sir, I will charge my laptop.
Okay.
Sir, what is the number that you have written after 0.25?
That is mod of 1 minus 1.25. Mod means you have to take the positive values. And then minus 2.25 in mod. Mod, you know now, modulus function. If any number goes in modulus function, you have to take the positive only. So that 2 straight lines that I've drawn, that means modulus function. Modulus function means if any number goes inside it, you have to take the positive of that particular quantity only. Even if it is negative, it will become positive. If it is positive, it will remain positive.
Sir, I'm getting
That is good. Yeah.
Sir, I'm actually getting 1.5.
1.5. Rohit said minus 1.5 now.
Sir, I'm getting 1.55.
1.5. Okay. So 1.5 I'm taking based on your observations. So 1.5 is my mean error. So I'll be writing the exact measurement of this quantity as exact measurement is exact result expression is like this, plus minus this much. How much? Delta A bar. Mean value of observations and mean value of error. So what is mean value of observations? That is 4.25 plus minus mean value of error is 1.5. Right? Understood? Now, there is a term called percentage error. Percentage error. Percentage error. So percentage error is, what was your error? My error in the last previous case was delta A bar, this is what we say error. What was my average observation? My average observation was this times 100. And this is what? Nothing but relative error. So relative error into 100 is percentage error. Okay. So if I give you the example of last case, I got the error as 1.5, exact value is 4.25. So what is percentage error then? So 1.5 by 4.25 into 100, this is my percentage error. Understood or not, everyone? Good. Write it down. Done. I've written all the notes of this page. Okay. So today we discussed about the uses of dimensions, and then we did errors. Errors, we have few more topics left. I guess half an hour class or something like that is left. So that will be completing in the next class and this chapter is over. Right? Any doubt till here, anyone? Good. You're solving questions?
Yes, sir.
I'll try to like arrange one question class if it is possible. And I'll check that, because solving question is very important. If you don't solve that, all the teachings are just vain. No use. You won't be able to get. If you see these things now and you see the questions, though both are, all of them are like totally different things. You should solve some good books like H.C. Verma and D.C. Pandey. If you don't have, get it right now. Class 11th, H.C. Verma and D.C. Pandey are the two books at least that you should solve. Right? So solve all those questions and then you get it. Now we'll be ending the session. And then after 15 minutes, we have the session for maths, right? We'll be joining it there. And there will be completing sets today and relations today. And then we'll do the functions after that. Okay. Go have a break, everyone. And then come back fast. Exactly at 6:15. Okay.
Thank you, sir.
Now no maths class only. I think I was going for the